Yeah, it's harder to draw the picture here. Okay, so this is the picture. Okay, so this is a picture we're going to make. Okay, that's the question. So we have the following parts. Okay, the first part we can use is this one. Okay, the second part we have this type. Okay, so then the third part, that's all kind of things here, right? This is going to be actually just missing the one corner here. Okay, then the fourth one, it looks like that. It's harder to draw it. Okay, and the fifth one will be something like that. Okay, so the question is, which one you cannot use to make the above picture? Okay, right? There are several of them. So it's clear to me the first one is okay because that one above picture consists of 3 parts like that. Okay, that's trivial. Okay, then you have to look at the second one, and you have to look at the third one, right? The second one, I think it's still possible. This can be done in the, yeah, you can, let's see. So C, D, I think C and D is okay. And you use this picture. Yeah, that's for C. It's hard to draw the picture here, right? And this part is missing, so here looks like that. Okay, then you have the other one. The other one is I'm going to use the different colors so you can see. Just rotation by rotation. It's, yeah, right? Okay, I'm talking about this one. Just look at that, right? So C is okay, then yeah, then the actually consists of 3 pieces. 3 pieces. Now, how do you extrude one of them, which is not possible, is in order to make a picture like that, okay, you total have 24 triangles. 18 triangles, right? 6 plus 6 plus 6. Total, right? 18 triangles. Then yeah, so this is obvious, okay? This is obvious, okay? Now you only have 2 left, right? You only 2 left. So which 2? Yeah, which of them is obvious is okay. I think that D is impossible. Okay, it's no matter how do you put there, it will block the, for example, you have, yeah, it's the whole piece, right? 1, 2, 3, 4. So if you choose one of, if you put it over these 3 hexagons, then it will separate into 2 parts. So cannot be connected. There's no way you can put another one into that. Okay, 1, 2, 3, 4, 5, 6. So I think the third one is impossible. This is possible. So you go around. It's easy. Maybe maybe you don't need to try one by one. You should quickly look for the one which does not, you cannot use it to create such ornament, okay? So, so you take a quick observation. Some of them already, it's obvious, right? A and E is obvious. And B is a little bit difficult, C is a little bit difficult to see. But if you look at the D, you find that the D is very long, okay? When you put there, no matter where you're going to put it, you can divide this ornament into two disconnected parts. There's no way you can put another one to connect it, okay? Yeah, so this is then this is where you decide, okay? So in order, if you give a limited time to answer this question, then you should cross those obvious ones which you can use. Then only have a couple of them left, okay? Then this couple of left, then you look at which one you cannot use to create, yeah, that's much, yeah, which one you cannot create this ornament, okay? And it's obvious right now, it's a D, okay? Because once you put a D over somewhere here, it's such like, let me show you the picture. So for example, you want to use this one, right? Then you separate this ornament into two parts. There's no way you can connect. Okay. So this is about the problem I want to discuss, and then let's go through the other. Let's discuss other problems. Okay. My first problem, it's easy. I begin with these easy problems. Okay. So here's, so Aaron was born on Kevin's birthday, and which birthday? 5th birthday. Okay, sorry. Okay, my question is, how many years later will Aaron be twice as old as Kevin? Okay. Yes. Well, 5, 4, 5, right? So yes. So this is the way, it's already Kevin, right? So you look at, right? Ellen was born, so Ellen will be twice as old as Kevin. Kevin's, wait a minute, yeah. No, how many is Kevin? That's opposite way. Yeah, so no, you didn't read my question yet. That my name is Switch, okay? So will be Kevin, okay? Will be twice as old as Ellen. So this is a Kevin, okay? This is Ellen, okay? So twice means you double Kevin's age, okay? So this is Ellen. So clearly it's 5 years, here's 5 years. You just draw the picture, that's the easy part. The next one is not that trivial. And before I do this problem, I'm going to discuss a little bit, okay? How do we add them together like those numbers? 4 and 5, 6, okay? Plus 2, 13. Question, right? Do you still remember how to do it? So this is just add a sequence of numbers. Okay, start from 1. So the idea is you cannot do one by one. It takes too much time, right? Sometimes I have like a 97, right? So the idea is to assuming this is already a sum, right? You reverse the order okay? And add them together. But this time when you add them together, we organize it. So this will be add them vertically, okay? Then you will always get 14, 14, 14. All right, when you add the 14, how many 14s there are? 13 times 14. Okay, this is many numbers. There are 13 such numbers there. So 13 times 14 gives you a total sum, but this sum will be double of the original one, right? So the answer here will be 13 times 14 divided by 2, okay? Okay, so this is the way you get, otherwise, you see, you have to like 1 plus 2, it's 3, 3 plus 3, it'll be 6, 6 plus 4, 10. But that takes much longer. If you're given 27 numbers, it's harder to figure it out. Okay. All right. So now our next problem is I divide 26 pieces of candy among several children. I don't know how many of them, okay? Okay. So the condition here is that each child received at least one candy. Okay. And another condition is everyone received a different number. Yeah, everyone received a different. A different number of pieces of candy. So question is, what is the greatest possible number of children that receive the candy? Okay. Yeah, you understand the problem, right? What is the greatest, trying to figure out the greatest number of the students there. It's not, right? Okay. So you have a 20, you see, the idea is that you want to distribute them to as many as possible. So you cannot increase, you have to give them as less candies as possible, right? They have more students receive the candies, right? That's the idea. So you have to begin with one. The first one get one candy, right? The second one get 2 candies because you can give him 3 candies. You give them in the order, okay? The number of the candies increases. The number of the candy increases, okay? So each time. So the smallest number of pieces of candies will be 2, right? Then you can have as many of students receive the candies, right? Then the third one will be 3. The fourth one you receive 4 candies. They must have different number of candies, and so on, right? So the question is, what is the greatest number of students, right? It's there. So you will see that when you get to 6, 7, I think that is going to be, let's see, how many? So here you will, 6, right? And here's 10, then 15, 21, this is already 28. So you don't have enough candies for 28, right? You don't have right? So you cannot have 7 students. Otherwise, you need 28 pieces of candy. So you can only have 6. how many? Yeah, that's what I think, right? So the idea is, hold on, yeah. So all the students must have a different candies, right? Right, all the students must different. Then you're trying to give candies to as many students as possible. So you have to give them as less candies as possible, but they're all different. So 1, 2, 3, 4. Of course, to the sixth one, you can give all of them because to here you have 21, right? Yeah. 15 plus 6, 21. So you have 26 candies, right? So you can give the rest of them to the sixth one. But definitely you cannot have more than more than 6 students. Otherwise, the minimum number of candidates you should have 28. Okay. So the answer is, yeah, no more than 6. No more than 6. Cannot have 7. Okay. First of all, you just add them together. You will see if you have 7 students, minimum you need 28 candidates. Okay. The minimum you need 21 candidates. That's impossible. Okay. So this, but you have to, yeah, you have to look at, yes, you know, you have to, yes, do some analysis. See, oh, I want to have as many students as possible, distribute candies, but every time you increase by 1, that's minimum increment. Okay? Then if you have 7 students, you must have 28 candidates. That's impossible. All right. My next question is, this is a number theory problem. Looks like a geometry, but it's a number theory problem. Okay, there are squares and triangles on the table. Okay, I count the vertices. I tell you they have total 19 vertices all together. Okay, my question is how many triangles are on the table? On the table. Right. There are possibly more than 1 solutions. Can you, yeah, please work on this problem to see if you can get. Okay. Oh, you have only 1 equation, right? Now you have a squares. Square gives you 4 vertices. And triangle gives you only 3 vertices. Okay, total you have a 19 vertices. Definitely there are some triangles there. You cannot have all the triangles. Why? If you have only triangles only, then 19 is divisible by 3, right? 19 is not a multiple 4, it's not a multiple 3. So you cannot have all triangles or cannot have all squares. Okay. Anyone can give me the answer? Yes. 5? 5 triangles?
4 square.
Yeah, 5 triangles, it's possible. You got 1 solution.
4 squares, 1 triangle.
4 squares, 1 triangle, that's a solution. 4 square, right? Yeah, 1 or 5, yeah, that's correct. So the idea is that you can, how many triangles, you just needed to look at 19, right? 19 minus 1 square is going to be, you know, is going to be 15. 15 is divisible by, right? it's going to be 3 times 5. So you can have a 5 triangles. It's possible. Then, and minus 8 is 11. It's impossible. It's not multiple 3. 19 minus 12, right? It's going to be 7. Not good, right? And 19 minus 16, you get 3. Yes, 3 is 3 times 1 triangle. Yeah, this is what you do. You list all the, possible cases. Right? Now in mathematics, how do we set up equation like that? You can assume there are you can assume there are n squares and m triangles. You have to get 19. So you get an equation like that. Here n, m are positive integers. And you're trying to solve this single equation, then you have many solutions. Positive integers, okay? So, but we don't need to set up like that. We just list all the cases and you figure out there are 2 solutions, okay? Yeah, 2 solutions. Okay, I want a similar problem maybe in the following. Right. There are 13 boys and 7 girls were members of the club. Okay, I don't know what is that club. And every week, okay, new members added. Okay, 1 boy and 2 girls. Okay, how many members will this club have when the number of the boys is going to be equal to the number of the girls at the moment, right? All right, so you begin with the number of the boys, right? So you can, begin with this is the boys, that's the girls, right? Draw the picture, right? When you solve the problem. Here's a 13, here's 7. But every week, you plus 1, but you have to plus 2, right? Right? Then you plus, you have another one, you get another 2, right? And then so the number of the girls increases. And the number of the boys also increases, but the increase is slower. Okay? So each time you just calculate the number, right? So here you got 14, yeah. So what you're gonna do is you just add a number here, like 14, then 15, right after you add this, right? Then you got 16 and the 17, and here you will get 9, 11, right? And then and the 13, then 15. It's getting close. So the last one will be 18 here, and here it's gonna be 17, right? Yeah, 17. then add one more, you get a 19, then you get, here's 19. So total, right? Total will be 38. Okay. So this is so question is how many students there, right? So every time, yeah, you don't need so you don't need to know how many boys should be added, but you just increase by 1 each time. Other side increase by 2 each time, and you see that when the boys number reach 19, the number of the girls also reaches 19, so they're equal. Okay. Then the answer will be 28. Now, if you are in the basic math class, how do you solve the problem? The problem is that you assuming you are going to add the number of the boys, right? So 13 plus n, that should be equal to 7 plus 2n because the girls will be doubled. And from here, you can solve the equation, okay? You can solve the equation. You can subtract n on both sides. Then you get 13 equals 7 plus n. Then you subtract 7 from both sides. So you get, right? How to get 7, right? It's going to be 6. So n is a 6. After 6 boys added, then the total number of students, just add them together, right? 13 plus 6 equals 17 plus 2 times 6, right? Which is going to be still 19. Then 19 plus 19, you get 38 students. So that is another way to solve the problems. Okay. Okay, I said please do not type anything not related to the math problems here, okay? Otherwise, I'm going to kick you out. I can delete you from the list. Okay, stop it. Okay, so our next problem, I try to give you two different ways to solve the problem. And one is a little bit advanced using equations. So then some students can catch in and learn this quickly. Okay, the next problem is how many 3-digit numbers are there, okay, with the following condition, such that the sum of their digits equals 9. Okay, so equals 9. Okay, so that means such like 1, 4, and 4, right? And this 1 plus 4 plus 4 equals 9. Yeah, but just 2 minutes there, right? The question, how do you calculate? Yeah, you have three digits. 3 digits you have to choose, right? So I suggest you do the following. If you have, yeah, let's write down like this. 3 digits in this form, 3 digits in this form, right? And it's possible the last one will be 9A and B, okay? So you just need you have 9 groups here. But in each group, you figured out the number of the digits, number of the such 3-digit number, okay? So the sum here is A plus B should be equal to 8, right? Now A plus B should be equal to 8. how many such combinations there? You can A equals 0, B equals 8, A equals 1, B equals 7, right? So A is from 0, 1, that's it, right? All the way to 8. So you have 9 choices, okay? That gives you 9. And then here A plus B equals 7. So the sum of 2 digits is 7. How many possible 2-digit integers there? Not just 2, how many pairs of such numbers there, right? So you can, the first one is 0, then second one should be 7. First one is 1, then second one is 6. 1 plus 6, 1 plus, 2 plus 5. So total, you get 8. And so on, just decreasing. And you can see the pattern, right? And here must be 0, 0, because 9, 0, 0, the sum is good. So just only 1. Okay? So yeah, you figured out the number in each such group. Then you add them together. It's 1 plus 2 plus 3 all the way to 9. Okay? And this another problem. How do you add them together, right? If you don't know the formula, you can try this. It's 9 and 9 and 8 and so on. Okay? And the last one is 1. So add them together, you get 10, 10, 10, 10. Have 9 tens divided by 2. It's total 45. Okay? So you're going to have 45 such 3-digit numbers. Okay? So you are dealing with 3 digits, and it kind of one equation. The sum of the 3 digits is going to be 9, right? So you divide them into 9 different groups. Each group you figure out the number, and you see the pattern. It's decreasing from 9 to 8 to 2 to 3. So then add them together. Okay. So you will see that we always dealing with the sum of the many numbers, right? From 1 to 2, 3, all the way to 9. Right? So if I change the if I change the problem a little bit, let's redo the problem here. I'm going to change the problem here. How many? Yeah, I'm going to ask you to do that. How many 3-digit numbers there are there such that the sum of the digits is 6, right? Equals 6. So please do this problem. Hey, Justin.
21.
I know. Don't type too many. 31. Okay. So you have a 3 digits, right? Add them together. The first digit must be 1, 2, 3, 4, right? So you can begin with 1A, when in that form, 2AB and 3AB, right? And the last one will be, and must be 0, 0. Okay, so clearly if you know how to do it, and here A plus B, the sum of these two digits must be 1. And here the sum of these two digits must be 2. And so on. Here the sum of those two digits will be 5. So you can see that here is 1, 2, 3, all the way to 6. This is a total number of possibilities here. So the answer will be 1 plus 2 plus 3 plus 4 plus 5 plus 6, and this is 21. Okay. Yeah, that's easy to add them together. Okay. So you know how to do it. Okay. Yeah. A plus B equals 1 because A could be 0. That's the reason that is going to be. Okay. That's why you have to. Okay. Now I have another question. Let's do another question. Problem here. Okay. So so Ted has as much money as Will, and Kevin. Okay. Will has $20 less than Kevin. Right? The three, let's say 3 boys have total $60 all together. My question is, how much money does Will have? Right? All right, so we get different answers. Okay, it's 30 as much as Will. Looks like Nathan says 5. Will has 20. Kevin's 5, maybe. All right, so let's do this way. Okay. I want to see the total, you see, $60. So forget Ted, right? Kevin, Will, and Kevin, right? Kevin. So their total, how much, right? They have a $30 total. Okay. And Will has $20 less than Kevin. Yeah, let's try to see the set. Okay, if you want to solve using equations, this is what you do. Okay, you have let's see. I'm gonna this is the wrong picture. Let me. So you let you denote, yeah, and then I draw the picture for you. Okay, so what you have here is Kevin's money plus Will's money is going to be 30, right? Okay. Now Kevin has $20 less than Will. Will has $10 less than Kevin. So Kevin, the difference between Kevin's money and the Will's money is going to be 20, right? Okay. So if you know how to solve the equations, okay, you will see that from here, what you do is you add them together. I'm going to show this, right? Yeah, you add them together, and double of the Kevin's money is going to be 50, okay? So Kevin must have $25, okay? If $25, then the Will must be $5. Okay? So this is a powerful of the equations when you do the problem. Okay, you don't need to draw the picture to figure it out. Okay. Right? Yeah. Another way to do is total is 30, right? I'm trying to use a picture to compare. So how can I mark it? See, Kevin, Will has $20 less than Kevin. Let's do the comparison. Kevin, right? So this is the Kevin's part. This is the Will's part. Okay. Compare with the Will. Okay. Compare with the Will. William has 20 less. So it's $20, right? And this will be Will too. Right? Okay. So that means a total is a 30. So double Will's money plus 20 is going to be 30. You see that, right? So if I subtract the 20, look at this picture. Add them together, right? Double of the Will's money plus 20 equals 30. So Will's money should be 30 minus 20, but divided by 2. So that's why it's 5. This is another way to think about it without using the equation. First of all, you draw the whole line segment and divide into, yeah, one part represents Will, one part represents Kevin, okay? Then for this piece of Kevin, you cut off $20, okay? So it's W, 20, W. The total will be 30. W plus 20 plus W plus 30. So double of the W should be 10. The W should be 5. Okay. So 5 plus 20 plus 5 is going to make it 30. Okay. That's what we do. You don't need to list two equations without drawing a picture. Okay. A picture helps you to understand the problem. Okay. Yeah. Picture helps you to understand the problem. For this elementary mathematics, you are not required to set equations. But if I'm able to understand my first part, and then you are pretty advanced, you can quickly, learn the abstract mathematics thing. So this is important later on. We're going to learn how to set equations to solve the problem. Okay, and this is the two equations. And how to solve them? I add those two equations together. I call the equation 1 and call equation 2. And then when I add those two equations together, I get rid of the W. k equals 50, then you can solve for k, okay? And the 2 times some number equals 50, that number must be 25. Now once you get 25 for the k, then you can easily get the w, right? For example, here, 25 plus w equals 30. The w, of course, must be 5, okay? But if you find out that is pretty challenging, then this is a second method. You draw the picture, forget Ted, okay? You know, Kevin's money plus Will's money is $30. So you draw the picture, add them together, then you have to use the second condition, right? Kevin has $20 more than William. So it should be William plus 20. Then if you look at the whole picture, only consider William, forget Kevin. Then you will William plus 20 plus William equals 30. So William must have $5. Okay. Now, by the way, I give you the answer key. I noticed that the answer key is prepared by somebody else. So it's not guaranteed the answer key is 100% correct. Okay. So if you happen to have some question, some problem, your answer is different from answer keys, discuss with your parents. Okay. Maybe your answer is still correct. Okay. Does not mean. Okay. A typical problem is from the last homework. Okay. Let me copy down the problem. And I hope already you did it. And grandma, okay, give each of her grandchildren and 10 pieces of candy, still candy problem, okay? There will not be enough for one of the, not enough for one of them, okay? Okay. Then if he changes the way to give the candies, give each one 8 pieces. Then she find out she would have 6 pieces left. Okay, how many grandchildren does she have? All right, the answer key says 8. Well, 8 is the solution. Just like the problem I asked you, right? There will be multiple solutions possible. Okay. So the idea is you draw the picture. Okay, those are the grandchildren. We don't know how many. Let's stop here, and everybody get 10 pieces of candies. Then for the last one, it's not enough. Okay, some left, maybe one. Not enough means could be here. Sorry, no candy left for the last one. Then sorry, I have only 1 candy or 2 candies. We don't know, right? Yeah. They say, okay, we're not going to distribute in this way. Okay, so you have to distribute 8 pieces. Okay. And then the last one also get 8 pieces. Then 6 pieces left, extra. Yeah, what is left is actually 6 pieces. All right, now you have to solve the problem. Okay, so that's a picture, right? Do the comparison, yeah. So do the comparison. Yeah, please do not change your setting, okay? Benjamin, turn off the camera. All right, so each time, imagine you have two extra left, like when you distribute among them, right? 8 pieces of candy each time. So you have a 2, 2, 2. But that's 2, okay? You compare with the above one, okay? And this is a strange number, right? We don't know. So how many candies you left is actually the plus the question mark money. That's supposed to be 8 plus 6, right? Total. That's the idea. Okay, you have, the first way you distribute the candy is 10, 10, 10, 10. The last one you don't know, right? Then you change the way to distribute candies. So 8, 8, 8. Each time you have 2 left, right? But also have to plus the last one, which you don't know how many, right? Maybe 1, maybe 0, right? And add them together should be equal to those candies you have left after you distribute all the candies before the last one, to the last one. So this is a 14. Okay, a mod of 2 plus some mystery number should be equal to 14. So that number definitely must be even, okay? And that gives you the, so it must be even because 14 minus that number is divisible by 2, okay? So that number we don't know, right? I call the x, right? This could be 2, could be 0. When x equals 0, and I'm going to call this as the number of students, okay? Number of the grandchildren. This is not the exact, plus 1 will be total number of children, okay? So then that would be 14, 14 divided by 2, it's gonna be 7, okay? 7 plus 1, you have 8 grandchildren. Why is it 1? Because I only for the first, except for the last grandchild, okay? Then x is gonna be 2, and that'll be 14 minus 2 is 12, divided by 2 is gonna be 6. So 6 plus 1 is gonna be 7, okay? Then n equals 4. 4 is going to be 10 divided by 2, it's 5. So you can have all possible solutions. You can also have 6 grandchildren, okay? Then x equals 6, 6. Then you get, you can get 4, okay? Okay, then x equals 8. Okay, that would be 6, that would be 3, and keep it going. X cannot be 10. If x is going to be 10, and that is, it's not y cannot be 10. If it's 10 already, you cannot say that's not enough candies, right? So this x could be 0, 1, 0, 2, 4, 6, and 8. That's it. Actually, there are 5 solutions here, and all of them are possible. Okay, all of them possible. The total. Let's assume that let's look at the second case. Okay, why it's possible? Just look at this case. Okay, just look at this case. So you have 5 grandchildren, right? Just look at this case here. 5 grandchildren. Total candy is, it depends on how to distribute. The first way you distribute is going to be 4 times 10 plus 6. Total is 46 candies, 46 pieces of candies. Another way you distribute is 4 times 8, right? And then you have this many, right? And also 46. You see that, right? So everybody get their total 5 grandchildren. The first 4 you get 8 pieces. The last one you get 8 pieces. Then you have 6 left. If you want to distribute 10 pieces of candies among those 5 grandchildren, the first 4 get 10. The last one, oops, that's only 6 left. Yes. Do you have a question? I know. I just say this is one of the solutions. So how many solutions you're going to have here? That would be n equals 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Of course, this is a multiple choice problem. They have a 4, 6, 8, 10, 12. From there, you have 3 choices. Okay, 4, 6, and 8. But actually, if you forget this is a multiple choice problem, you are going to have this many solutions. Okay, they are not, and you can check that one by one. You know, even the last one. Let's look at this one. Okay, if you look at this one, how many can, right? You're going to have only 3 times 10 plus 8, and total is 38 pieces of candies grandma have. But they only have 4 children. The last one get 8 pieces. The first 3 get 10. So that's why it's not enough for the last one. Okay? Not enough means nothing left. It can be not enough, as same as, you know, as like other students. So that's my understanding. Okay? You cannot say not enough means nothing left. Okay, for the 4th grandchild. Then you change your mind, you get 8. Okay? Then 8 plus 8, okay? And have 6. So you still have 38 candies, right? So the 4th one is also get 8 pieces of candy, then have 6 left. This is what is left. So there are solutions, right? Okay, now, if you don't want to do that using mathematics, using equations, how do you do that? You can assume the number of the, so let n, let n plus, I can use that, let m to be the, m is going to be the number of grandchildren, okay? So the number of the candies is going to be you calculate in 2 different ways. You have a 10 times n minus 1. You have something left. Okay, not enough for the last one. But you can also have 8 times m, then you have 6 pieces left. And from here, you're trying to solve the equation. Okay, you are able to solve the equation. And then there was choices for, and you take the difference, you will see that if you take the difference, you will get, you can find all the possible solutions, right? So the difference, this 2 difference, what do you get? 10m minus 10 plus x, okay? So 10m minus 10 plus x equals 8m plus 6. Then add them, subtract from here 2m, then you get 10 plus 6 minus x. Then you try to find all the solutions possible. So x still could be 0, 2, 4, 6, 8. Then you find m, okay? Then you solve for m. So m is going to be 8, 7, 6, 5, yeah, and 4. Okay, got it. So see you next class.